To Cambridge Chemistry uh, with sarwatAhmed. Be sure to like the video and subscribe. It really helps the channel to grow. Today I will discuss some past paper questions of mass spectrometry for AS level. You know that this topic is recently added for this year from this year in the AS levels. So this is question from paper 4 because previously it was in paper 2 A level syllabus, A2 syllabus. So let's start. This question is about compound TCXHYOZ. Part of the mass spectrum of T is shown. The peak heights of M and M plus 1. Peaks are 33.9 and 3.4. 33.9 and 3.4. So this is first question. Calculate X, the number of carbon atoms present in T. So I have discussed the formula to find out number of carbon atoms in previous video. So this is the formula to calculate the number of carbon atom. 100 divided by 1.1 into m plus 1 divided by m. So m plus 1 and m, the relative abundance of m and m plus 1 is given. So by using this expression I can calculate number of carbon atoms. So is equal to 100 divided by 1.1 into m plus 1 is 3.4 while m is 33.9. So by calculating this I have 9. The number of carbon atoms in T is 9. So next question is deduce the molecular formula of T. This is C9 HY and OZ. So I have discussed earlier about that the first peak that is of molecular mass. This peak represents the molecular mass of the compound. This is the base peak and it is the molecular mass of the compound. It means C9 HYOZ is equal to 150. So when we identify carbon 9, so carbon 9, we know that carbon 9 is equal to 12 into 9 is equal to I use this space for working. So if carbon is 9, C9 HYOZ, this is equal to, this is the molecular mass, this is equal to 150. Now we know that number of carbon it is 9 and AR of carbon is 12. So 12 into 9 is equal to 108. Now subtract this mass from 150. 150 minus 108 is equal to 150 minus 108 is equal to 42. Now we can predict oxygen atom first and then Y. We know that if 42 is there, so it means that number of oxygen atom can be, if number of atoms can be 1, so that is equal to 16. And if number of atom is 2, oxygen atom is 2, if O2 is there, then it is equal to 32. Now add this oxygen atom, 108 plus 32 is equal to 140, and total mass is 150. If we subtract 150 minus 140, that is equal to 10. First predict the number of oxygen atom, then you can predict the hydrogen atom of this compound. So number of oxygen atom is 2 and left behind is 10, so 10 will be the hydrogen atom. The formula is C9H10 and O2. The mass spectrum has peak at mass over charge ratio 119. Identify the fragment lost from T to produce this peak. So this is the peak at 119. So if peak at 119 it means that some molecules lost from this whole molecule. So if peak is at 119, we just identify that which fragment lost from T to produce this peak. We have C9H10O2. This is the carboxylic acid, and you know that carboxylic acid and ester are isomers of each other. So ये भी हमें माइंड में रखना है कि आपके पास जो है वो आइसोमेरिक कंपाउंड में से भी कोई पीक लॉस हो सकती है. सो इट मीन्स इफ वी नो दैट 119, so now first find out that which fragment is lost by subtracting 150 minus 1. Fragment lost is equal to 150 minus 119. So this is equal to 1118 minus 150 minus 9. So this is equal to 31. A most common peaks are CH3, this is equal to 15, C2H5, that is equal to 29, and C3H7, that is 43. So this is methyl ion, this is propyl, ethyl and propyl. These are the common fragments formed during the on the mass spectrum. So this is 31 is above than 29 and below than 43. So in between these two, so we can identify that if this is R, this can be ester as well. So it can be, if it is ester, so this is C double bond O, we start from one carbon, this is O and this is CH3. So if molecule electron lost from this region, so this is the molecular ion and this is RCO is the molecular ion and OCH3 is the lost fragment. So OCH3 oxygen is 16 carbon is 12 and hydrogen is 3. 12 and 16, this is equal to 31. So identify the fragment lost from T to produce this peak. So 31 OCH3 fragment is lost uh, from this peak. So next question is about infrared spectrum. T is shown. So this is the infrared spectrum. Identify the type of bond responsible for each of the peaks V and W. So this is V, and this peak will be at sharp peak at 1500, 1600 and 1700. So according to the data booklet, at this wave number 15, 1700, this sharp peak is above of C double bond O. If we look at the data booklet, and W peak is at about 1000, 1100, 1200, and this is around about 1290, 13, 14. So this peak is of CO. So V is C double bond O peak and W is CO. And इस spectrum से we can identify that fragment lost can be ester as well, because in infrared spectrum C double bond O like ester peak is visible. So there is no broad peak for OH, no broad peak over here. So that's why this is ester peak. Functional group is ester, and in this compound OCH3 might be lost from this molecule. So this is another question of mass spectrometry and infrared. Compound F contains elements carbon, hydrogen and oxygen only. All carbon-carbon bonds in F are single bonds. The structure F was analyzed by mass spectrometry and infrared and NMR spectral. Mass spectrometry and infrared topics are in AS syllabus, while NMR in A2 syllabus. The mass spectrum shows the mass over charge value for M peak is 90. The ratio of the heights, mass over charge ratio mean if so calculate the number of carbon atom in the molecule of F. We use the same formula, N is equal to 100 over 1.1 into M plus 1 over M. Now we have N is equal to 100 divided by 1.1 into M peak is 22.1, while M plus 1 peak is 0.7. This is 0.7 divided by 22.1. So by calculating this value, N is equal to 70 plus 24.31. So this is equal to 2.8. So it means the whole number, that is 3. Suggest the molecular formula of F. If we know the number of carbon atoms C3, so this is C3, and the m over charge ratio, mass over charge ratio, is equal to 90. It means this compound, F compound, contain carbon and hydrogen only, C, H and Y, oxygen. So this is equal to 90. So carbon is, so we have find out the number of carbon atoms, so this is C3. So if C3 is equal to 12 into 3, this is equal to 36. Now subtract 90 minus 36, which is equal to find out the number of oxygen atom first, then afterwards hydrogen. So 90 minus 36 is equal to 54. So how to calculate the number of, how to predict the number of oxygen atoms? We know the AR of oxygen is 16. So if we have this number, so predict the number of oxygen atom present in this compound. So by dividing 54 over 16, so this is equal to 'approximately 3.3. So we can think that number of oxygen atom will be 3, might be 3. So if number of oxygen atom is 3, then afterwards we can find out the number of hydrogen atom. So this is 12 into 3 plus H plus 16 into 3. So this is equal to 90. 36 plus H plus 48. 36 plus 48 is equal to 84. So this is 84, and left behind will be the hydrogen atom. 36 plus 48 is equal to 84. Now subtract 90 minus 84, this is equal to 6. So in this way we can predict hydrogen and oxygen atom. So hydrogen will be 6. So the formula is C3H6O3. So next the infrared spectrum F was obtained. Use the data booklet and your knowledge of infrared spectroscopy to identify the type of bond and functional group responsible for these 3 absorptions. So if we look at the data booklet, 3350 absorption will be of broad and strong. So when at 3350, that is broad and strong peak are there, peak is there, then type of bond always will be OH, and functional group is hydroxyl. And at 2680, very broad and strong peak is of 2680. that is of C double bond O and OH peak. It means that is carboxyl. And 1725, this is functional group C double bond O peak. We will look at the data booklet. So at 1720, the strong peak is of C double bond O, and very broad and strong peak at C double bond OH is the carboxyl, and only hydroxyl peak is present at 3350. So this is the carbonyl peak. So it means that there in this compound carboxylic acid as well as carbonyl functional group is present in the above compound T. So there is another question of mass spectrometry. The mass spectrum shown was obtained from a compound of formula CpHqX, where X represents the halogen atoms. So I have earlier discussed in my previous video that if two base peaks are present at the same height, like this and this, so X we can identify from this peak. So this is first peak is present at like oh, this is 125, this is 124, and this is at 122. So these two peaks are equal height, so it means X will be bromine, because abundance of two isotopes are approximately equal. 50% of 79 bromine has two isotopes, we know, bromine 79 and bromine 81, or the abundance is 1:1. So that's why if two peaks are at equal heights, first two peaks are at equal heights, it means that is of the halogen is bromine. Okay, the relative height of the M and M plus 1 peak are 9 and 0.3 respectively. Calculate the value of P. Use this for value and the mass over charge value of the molecular ion to calculate the value of Q, and hence the molecular formula of the compound. Show your working. N is equal to, first find out the number of carbon atom by using this formula, 100 over 1.1 into M plus 1 divided by M. So N is equal to M peak are 9 and 0.3, peaks are 100, 1.1 into M plus 1 is 0.3 divided by 9. So this is equal to 3. It means we have C, P, Q and X. C, P, H is Q and X is halogen, that is equal to 122. The mass is equal to 122. It is equal to 122. So we know the bromine atom, and left behind will be the carbon. Carbon first. In this question we find out the bromine, and by using this formula we have identified 3. So it means the formula is C3H2X is the bromine atom, and it is equal to 122. Now 12 into 3 plus HQ plus bromine. So we have two isotopes, 122 and 124. So if we use 79, bromine 79, so this is equal to 122. 36 plus 79 is equal to 115. So 115 plus HQ is equal to 122. HQ is equal to 122 minus 115. So this is the 7. H value is 7. HQ is equal to 7. So the formula is calculate the value of Q. The value of Q is 7. So the C7, the formula will be C3H7Br. So this is the formula. Suggest a formula for the ion responsible for the peak labeled R. So this is at, and now this is the peak R, and identify the number of mass over charge ratio. 41, 42, 41, 42 and 43. This is at 43. Now we have C3H7 Br is equal to 122. So if peak is at 43, appear at 43. Now let's subtract 122 minus 43. 144, 122 minus 43. It means 79 fragment is lost. For example, this is C3. For example, if molecule CH3, CH2 and CH2 Br. So I think so electrons are removed from here, and bromine atom is lost from this fragment, and propyl ion, this is the peak of C3H7, that is equal to 43, and bromine molecule, bromine atom is lost. So suggest a formula for the ion responsible for the peak labeled R. So C3H7, we know that C3H7 positive ion and 1 will be the free radical. So this is the molecular ion, 12 into 3 plus 7, so this is equal to 43. So the ion is propyl C3H7 positive. In the fragmentation of alcohols which occurs in the mass spectrometer, small stable neutral molecules are sometimes produced. Suggest the identity of two such molecules, each with an MR less than 30. So two molecules which are mostly not appeared on the mass spectrum. So this is the molecule. MR less than 30. So there are many stable molecules which in this compound can be lost by fragmentation. So OH negative ions cannot cannot be detected on the mass spectrum. So this can be lost. Another possibility is this molecule also lost, carbon monoxide, and these two hydrogen also, and over here this fragment is also water is also lost. Water can be there. So different possibilities. Any alcohols. I will look at this compound, ethanol. This neutral molecule can be lost. Also H2O. If hydrogen OH is lost, water is lost, and then there is another molecule, for example C2H4 is also, there is another possibility, C2H4, and hydrogen molecule also lost. H2 can be lost. So there are many possibilities which has this is 18, C2H4 is 28, and this is 2, 28, So all possibilities are there: CO, OH, water. These two hydrogen can be lost, and alkene is there. So there are different possibilities, that is below than 30 mR loss. So write down any two. You can write down any two from these stable molecules which are lost from the alcohol mass spectrum. Hopefully you will understand this topic. You will to question how to solve these questions and how to use this formula to identify the number of carbon atoms in unknown compound. So if you like this video, please like and comment in comment box.